This is Scott from KIG. It is April 6th, 2021. Today we're going to do a couple runoff videos on this 2012 40-ton Riedel outdoor rated process chiller, which we've had in our shop here for a bit just to update, test, run, and fix a few relatively minor things. For the first video, we're not going to have it powered up because we're going to have all the side panels off, which are these here. Those side panels, very important, have to be on so that the unit does not go into a high pressure alarm. So this is a nice packaged chiller, meaning we have a stainless steel insulated glycol reservoir here, and we've been running and testing this with about 40% glycol concentration. It's going to go to a home in New York State, so that's about what we would recommend for an outdoor chiller there, 40% glycol concentration. The tank has its high level and low level float switches there. Has a drain here. This is a nice system in that it's a 2-pump system. In fact, the primary pump, or the chiller loop pump, is a brand new pump we did just install. So what does a 2-pump system mean? It means that the chiller loop pump, again, which is this new one, suctions or draws from the tank, and it comes up here. The discharge, and this valve we can leave open, discharges directly, or outputs directly. It goes behind the tank to the raised plate heat exchanger or evaporator that's right there. Then discharges back into the tank. Then the process pump is a slightly bigger pump here, this Grundfos pump. Draws from the chilled water from the tank and goes out to the process in the back of the chiller cabinet there. So we have 2-inch connections for our test loop. This is the output of the chiller, and we usually put on a flow gauge to test it, and we're just looping back to the input of the chiller. The chiller has its own, what the Europeans call a safety valve, which is a valve behind this insulation here, which is effectively a safety bypass valve. So if you were to deadhead the flow out at your process machines, this spring-loaded valve here behind this insulation would get activated, and you still get some flow coming back to the return line, coming back to the chiller. Under normal operating conditions, and we measured the amps, this valve here, which is for service, which again is the chiller loop, you can leave that wide open. You should not have to throttle that down from what we can see. We have 3 Danfoss scroll compressors, R407C, approximately 13 horsepower each. The compressors all have functioning and checked out heater bands on them. When you first get this chiller, you should have power to the control cabinet, and we'd like to see these on for at least overnight, ideally 24 hours, to get the refrigerant up to temperature. It does not have to do, or it has very little to do with the ambient temperature outside. You want these warmed up overnight, and the bottom of the compressor should be warm to the touch. The actual heater band itself will be hotter to the touch. You can do the tap test, but don't press your finger on there. So again, this is our brazed plate evaporator, 3 compressors, 1 refrigerant circuit. On this unit here, we do have hot gas bypass solenoid valve, and the hot gas bypass can be adjustable by going behind this box and making an adjustment. A hot gas bypass sometimes can be your friend and sometimes not for different applications. Some chillers don't even have it. Hot gas bypass is a method of capacity control. If you are running at lower tonnage or reduced capacity situations. The hot gas is will actually bypass gas in the circuit, and it will prevent short cycling of your compressors from starting on and off. In some cases, depending on temperature and certain applications, the hot gas bypass might be on for too long, which is what we find as chiller suppliers and constantly modifying and working on chillers for different applications. So we like to put in an actual switch, which we did here, on-off switch to turn the hot gas feature on or off. An example of why you would want to turn it off is if you realize that the compressor never turns off, you always hear the chiller running, in which case you'll want to turn the hot gas off, and you may find it operating a better scenario for you. The hot gas is nice for certain conditions in that it helps stabilize your temperature and maybe keep the compressor running for one of the compressors running for a half hour or hour or two while it's holding and keeping a particular set point temperature steady. Here in our control cabinet, we had our technician, I advised our technician to label all the key components in here. Up here are your overloads. All of them you'll see are in the vertical position. If one of these overloads trip, in fact you can see compressor 1, compressor 2, compressor 3, or fan 1, and then fan 2 of 3, fan 4 of 5, etc. There's five fans up above. Then you can see primary pump, secondary pump, tank heater. There's a heater for the tank. If those were to trip, the switch would go to that position there, and that's how you reset it. Down here we've labeled our compressor contactors, our pump contactors, our fan contactors. We have a cabinet heater thermostat, our tank heater contactor. We have tank heater thermostat, some of our terminal blocks in here. This is the main power disconnect here for our testing. We manually turn it to the right. Be very careful. Obviously, you should have an electrician power your chiller wiring accordingly. This up here, it looks kind of elaborate. This is nothing more than a cover to cover some of that main incoming wire. Nice little way to do it there. So what we're going to do is I'm going to put the covers on, and we're going to turn the chiller on and just go over the set point adjust. This is a brand new controller that we got. It was a little bit weather beaten from the prior operation. So in addition to a entire new controller, the unit also has an entire new primary chiller loop pump. So I'm going to put these covers on. We're going to start the unit up on our next video.